this is our time, and this is our height. Okay, so hopefully everything is going to work correctly. We don't have a lot of data points, but I think 4 will be enough. Now, if we really wanted to be accurate, we could go back and use a lot of other data points. But to put this into your calculator to do a regression, it is going to work like all the other regressions we've done. So we've done regressions in here a little bit where we did the linear and the quadratic and the quartic and the cubic and all of that stuff, and we were looking at those R values to see what fit best. So the first part is exactly like that. So you're going to press Stat and Edit. And if you've got any data in here, you're going to clear it out. And so and where you got repeating, just put several decimal places there. And we do want to be in radian mode whenever we do this. So you might want to just check and make sure you are in radian mode. So if you hit mode, which is right beside your blue button, you should see it is in radian mode. It's default for these calculators. So if your calculator's been reset recently, it should be there. All right, everybody okay? Got their data in? Okay, so if we want to be able to do all the things that we were doing yesterday with Desmos, which seemed to be working perfectly fine until it didn't on the homework. So if we want to do all that, we need to get a regression. We also want to store it in our Y1 so that whenever if we graph it or if we need to look at the table, that it'll be stored there. So we're going to go to Stat and then over to Calc, just like we do with all regressions. And if you scroll down, you have a sine regression for C. I think it's the last one. If you just hit the up button, it'll get you there first. So sine reg, and then you're going to click to store it. You're going to click vars, over to yvars, enter, enter, enter. Okay. All right. Maybe there's not enough data points. When I tried this on Desmos, because 15 doesn't work well on Desmos either, it had to have 5 data points. Maybe if we added another data point, it would be better. So let's go to Stat Edit. Let's look up another. More data, water levels. It's also kind of cool how it's not exactly sine. I wonder what makes it do that. Probably something to do with like the, I don't know. Alright, let's see. Show data listing. What about if we go back? Let's see, 2026. Let's just pick 7. At 7 a.m. it was 21.4. So we're going to add that. Let's see if it'll work if we add that. So at 7 a.m. it was 21.4. So you don't have to put your list in order for the calculator. So let's just do 7 and 21.4. Okay, let's try this again and see if it works. It does. Okay, I think that it must have 5 points to be able to do this, maybe. So, C, no, Oh, I've got some. Okay. All right. Let's try this again. Stat, calc, bars, Y bars. Did yours work, Casey? Yeah, bring it up here. This is a train wreck, isn't it? Ugh. Alright. Sure enough, it did. Stat, edit. This looks just like mine. Yeah. Did anybody else's work? Yours work. Kason, Sophie can get this to work. Nobody else can. Magic touch. Because yours is exactly what I've got. Exactly. And you did stat, calc, binary, bars, Y bars.
Are you kidding me?
Oh, hold on. Let's see. Stat, edit. No. Alright. We'll try something here. Alright, Cason's looks just like mine. And his works and mine does not. Let's try adding one more point just to see. Maybe it's possible he's got like an updated, a newer version of the calculator, and that's working better for him. Oh wait, where was I at before? I was here, 7, 24.1. Let's go. Let's go for 2, 14.91. 2. Please do not tattoo each other in class. 2 and 2 and 14.19. Alright. 2, 14.19. Stat, calc, bars, Y bars. Okay. I know. Let me see if my calculator's working. No? I don't know. And Casey's is working, and he has the same thing we have. This one is actually kind of old, but like half of my calculators are newer calculators, and half of them are older calculators. So it should be like half the class that it should be working for if that was the case. Cason's calculator was the one that we couldn't find yesterday. Maybe it was like it was taken by aliens and updated.
Oh yeah, was it Cason's taken?
His was missing. And it's returned with special powers, able to calculate something.
Did you put the repeating decimals on the everything?
I did.
I put like a bunch. Maybe that's what it was.
It should make a difference, though.
Well, it's not because my calculator is different.
This one won't work. This is one of the newer ones because when I got the newer ones, I specifically swiped one and put it at my desk because I wanted to have one of the newer ones. So.
Well, do you want to just copy my?
Well, no, not really, because I need to show everybody how to do. All right, let's try. I'm just going to go back. You guys can talk amongst yourselves for a minute. I'm going to try this other one and see if it works at all. Something's not right. Stat. It works for that one. This had 12. But I feel like 6 should work, though. 6 should be plenty, I would think. It worked for Cason? I tried that and it wasn't working. Let's see. Let's try. The order doesn't matter, but for some reason I'm going to try it anyway. Well, I put the 2 and 7 first, but yeah, you're right. Ah, let me fix it. Today is not my day. Okay. He's trying to keep me from messing up, but. This should not make a difference, but I'm trying everything. Okay. Well, this was a good idea. It has gone terribly wrong because only Cason's calculator is actually giving us. Cason and Sophie are the only ones that actually have. We cannot. So, only theirs are actually given an equation, and I do not know why this won't work. No. He does use the calculator a lot. I have not ever ran into this before. I'm usually pretty good. Like usually, if you say, Miss Hyatt, I got this error, I can tell you what you did wrong without even looking at your calculator. I'm usually pretty good, but this is new.
Would Coach Wood know? He definitely would. Me and Casey can go ask him.
Alright, you two go ask Coach Wood and see if he's got an answer for why Cason's work. Take yours, Cason, and show him yours is working. Go ask him. Yeah. All right. Okay. I don't know why this is not working. They've gone to find the answer from Coach Wood. This might be kind of like when I was little. I asked my mom one day why Daddy was so much smarter than her, because she went to college and he didn't, but he was so much smarter. I was like really little whenever I asked this question. Now that I'm an adult, I realize that's because Dad made up answers to things that he didn't know and just told us lies, whereas Mama actually told us if she didn't know. So who knows what type of false information I've believed all my life because of my father. But they might come back. Coach Wood may act like he's got an answer. Doesn't really. Even though it'll be hard to fake it on this one. So it worked. The calculator works if we type in this equation, the one that we used yesterday. It gives you a little bit different answer. This answer right here is what it's going to give you instead of the one we got in Desmos. But it worked fine yesterday in Desmos. So I am not sure why Kaysen has a magic calculator and why mine's not working. But let's do this, because that did not work. Look at your textbook, and if you don't have one with you because yours might be at home, you can share with somebody. Look at your textbook at number 6 on page 391. Number 6 on page 391. Yeah, there's no telling where he's at. He's in Coach Norman's room, I bet. I think I've been recording this whole time, so Leah will know all the adventures of today's class. She's going to be watching through this thinking, oh. Alright. Sorry, Leah. Today's not going well for us. Alright. Look at, in your book, look at page, come on, let me write. Hopefully this one's going to work. Look at page 391, number 6. Let's try that one. Alright, so, let's try this again. Yeah. Stats, edit. To clear, you go up here, highlight the L2, hit clear, and enter. Don't hit delete or it'll go away. Yeah, you can delete each one out individually or type over them, but if you want to clear the whole list, you go up here and hit clear and hit enter and it'll clear out your whole list. But be careful, because if you go up here and hit delete instead of clear, it's gone. And it's completely gone. So if this is something good to know for any state test where I cannot tell you how to fix this. Because if it's one of my tests, I'll tell you how to fix it. If you raise your hand. But if it's a state test, I'm not allowed to tell you anything about anything on that calculator. The only thing I can do is give you a new reset calculator, which sometimes doesn't even fix this problem. I have had it where it didn't fix the problem before. So if you go up here and you're clearing out those lists and you hit delete, it is going to delete the list where now I've got L3, L4, L5. If you go over, if you try to go back, it's L6, L3, L1, and L2 are gone completely. So if you accidentally do this at any time, some of these calculators, the full reset will fix it, but it's also going to clear out anything that was already in there and reset your R values and all of that other stuff. The quickest way to fix this is if you click Stat and go down to number 5 where it says Set Up Editor. And you're going to hit enter where it says done. If you go back to stat edit now, L1 and L2 are back. So, and if there were numbers in there, the numbers are back too. So it just like sends them away to hide for a while, and that's that. Yeah. Yeah, so if you want to clear everything out, like you got 9, 6, 5 in here and you don't want it, you go up here and hit clear, and it'll get rid of it. Okay, so let's type our data in from 6 there. So it's just the months 1 through 12. Good. Yeah, you're miraculous, so. So you're going to type all that data in there and make sure I got everything in right. Might need to get that checked out, Casey. Or it could be something with the special powers of your calculator. It might be like a magnetic force around the special forces of your calculator, possibly. Okay, I think I've got them all in right. Okay, let's try it this time. Stat, calc, C, and then I'm going to hit vars over to y vars, enter, 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 and I think it's going to work this time. Okay, I do not know why it would work for some of us and not for others on that other one, but you should get this equation. Are you guys getting that equation? Okay, so I'm going to write that down. So our f of x equals 11.837 sine of 0.554 theta or x, whichever one you want to use, minus 2.44. I'm going to keep 4 decimal places there to avoid having to round that weird, plus 53.355. Okay, so the steps for this are the same as they are for every other regression, except for you're going to pick C from the list instead of any of those other ones. I did not get an R value here to tell me how well this fits, because I do not have my diagnostics turned on. But if I did second 0 and went down to these there, diagnostic on, if I turn those on. Do you guys know how to pull up like the last thing that you typed in? If you do second enter, it'll pull up the last thing that you typed in. If you do second enter again, it'll pull up the thing before that and the thing before that, and it'll go on. So if you don't want to type everything else in, you could do that if you're repeating yourself there. This should give us the R value. Okay, maybe it doesn't give R values for sine functions. I think maybe it doesn't. Apparently they're not there. So there is no R value, I guess. Nobody else got it. Did you get an R value, Case? Or Sophie? I don't think there is an R value for this. Yeah. I think where this is repetitive, the process that's used for the least squares regression might not work with it being repetitive. Or it might just, or the calculator might just be programmed where it's not able to, it might just not be able to calculate it. I don't think so with the squares, but it may just not be programmed to, it might be too complicated for the calculator to calculate it, so that might make it not, they might have not have programmed it where it would do it because it'll take too long. Alright, so, but I'm not certain about that because I've never programmed a calculator or even came close to it. So, and it's been a long time since I did least squares regressions by hand. So, I might be forgetting something about that. All right, for this, let's look at the questions that go with this. It says find the amplitude of the sinusoidal function that models the monthly temperatures. And so amplitude for this one. Also, I meant to tell you guys, even though it doesn't matter because you couldn't do it right because Desmos wasn't working, the book does not use the graphing calculator to find the equations for these, so their answers are different than what you're going to get whenever you use the calculator to find the equations. I want you guys to use the calculator because I feel it is the best approach to this. So you could, like, by hand find, like, the highest point, the lowest point, the midline's halfway in between it, then find what the amplitude would be. You could do all of that stuff by hand, but the calculator gets us an even better estimation of this because it takes all of the points into consideration, not just the highest and lowest point. So I want us to use the calculator. So if you do check your answers in the back of the book for some of these, like the ones where you actually have to do the regression, it's going to give you different answers. 13 is the only one that might actually happen for, but 13 wasn't working for you guys last night anyway, so just know that they might be different. So the amplitude for this, for A, is 11.837. It is 11.837 what? We have months and we have degrees. Which one is it for this? If you think of what the amplitude is, right, you got your sine function. Amplitude is the distance from the midline right here to the maximum. That is a vertical distance, right? So that's why. So it is degrees for this. So the distance from the average to the highest would be 11.837 degrees. For B, it says find the vertical shift of the sinusoidal function. So the vertical shift, that's this number over here. So that is up 53.355. Is that degrees or months? It's degrees because it's vertical. So that's your y coordinate. What does this tell us? 53.355. What is that in terms of the months and the temperatures? It is average temperature for this location. Which is Seattle. Okay. So for Seattle, this is your average temperature. Kind of cool there, actually. For C, it says, what is the period of the sinusoidal function that models the monthly temperatures? For period, we do 2 pi over B. So 2 pi over 0.554. That is going to give us 2 pi over 0.554. If we really wanted to be most accurate, we could use that whole decimal right there. This is going to be good enough for us, I think. So we get 11.341. Is that months or degrees? Okay, that is months because we're talking now like the distance from low point to low point. That's a horizontal distance. So that's measured by the x-axis. So this is months. And Andrew, when we're talking about temperatures repeating, what should that be? Like in the real world, we know what actually happens. How often does it take for your temperatures to repeat whenever you're talking about seasons? A year. So if we looked at lots of years of data, that would probably be a lot closer to being exactly 12. But this might have been, since it's shorter, well, I don't know. This might have been a year where you had like a really warm summer, a really cool winter, something like that threw this off a little bit. But if you looked at more data, it would be closer to 12. And then for D, D asked you to write the equation that actually is this right here. They were doing it sort of out of order because they were writing the equation from the data. E says, according to your model, what is the average monthly temperature in February? How does this compare to the actual average? What month is February? Is 2. So since we stored this in our Y1, we can just do second graph and go to the table. Ooh, let me table set mine to go back to 2. If you go to the table, I've got 41.829. So 41.829. The other option for that, let's say this was a problem that just gave you the equation, you didn't do the regression for it, then you would just take 2 and plug it into your equation. So you could just do 11.837 times sine of 0.554 times 2 minus 2.4495 plus 53.355. So you could just type it in. You get 41 point. You actually get 8.8278 right there. So it'd be 0.828 if you did that. Why is that a little bit off from this? I rounded those points right there. So it throws it off a little bit. If you're talking final exam multiple choice question, you're going to be close enough to tell which one's right probably. And then the next one asks you for October. So what would you look at for October? 10. You just go to the table and you would look at 10, or you could plug 10 into your equation, so you get 53.918. So F there would be 53.918. And if you look at the table, October was actually 54. That's pretty close. If you look at February, it was actually 44. It's a little bit further off. So that might tell you that, like, maybe it was cooler in February, which is why the normal, so that's why it's not fitting quite as well. Okay. All right, questions about doing that on the calculator instead of Desmos? I think you guys should do pretty well with it because it is a lot like what we've already been doing with the other regressions. I wish Desmos would work though, because it is easier, I think. Especially because it gives you the graph right away. Like if you want a graph here, you got to turn your stat plots on and change your windows and all of those things. But you can still type if you need to see the graph for some reason, you can still type your data into Desmos and then type this equation you got on the calculator into Desmos, and then it will work that way. So, like for example, I just want to look at Desmos on this one. So, for example, if we type our data in right here, I like this too. Desmos like fills it in for you. So fast to type it in. Okay, so if we change this, let's see, we go from 0 to 12, and then let's go from like 40 to 70. So you see the graph there. Let's see if it'll work on this one, just because I'm curious. Y1 A sine B X1 plus C plus D. Nope, doesn't work. If I switch it, so it's on radians. If I switch it to degrees, and see, that time I switch it to degrees and it still doesn't work. I think it's just unreliable, so don't try to do this on Desmos. But what you could do is you could take that equation that we just got, let's do this. You could take that equation that we just got and type in f of x equals 11.837 sine 0.554 x minus 2.445 plus 53.355. Did I change it? I changed it to degrees. Go back to radians. Okay, and then it matches. So you could still use Desmos, but you're going to have to use the calculator to get the regression. But once you've got this, like if you wanted, and the nice thing about this, if you use function notation on Desmos, if I type in f of 2, it'll give you that 41.827. And if you type in f of 10, it'll give you that value there too. So it's an option there. If they ask you a question where you'd like to see the graph, you can type it in by hand. But unless Coach Wood and I figure something else out, Desmos seems unreliable for this, for finding the regression. So use the calculator for that part. I'll still allow you to use Desmos because it might help you on some of the other questions where you're given the equation. But the calculator will be necessary. All right, questions? Okay, so because we had trouble with that last night, what I want you to do now is use your calculator to do number 13, number 15. The calculator's probably not going to work on 15, except for maybe Cason's magic calculator. Let me see. Yes. Oh, she should. You can go check and see. Yeah, that's fine. Just make sure you go by the office there. Homework is just to finish all that other stuff there. Okay, so I don't think 15 has enough points to work on the calculator, so let's just talk real quick about what you'll do on 15. 15, you can try it on the calculator, but it's only got 3 points, so I don't think it works. 15 gives you 4:30 a.m. and 13.25 for your tide. And then at 10:50 a.m. You get 1.88, and then at 4:53 p.m. it says second high tide, so we're going to assume the same height of the tide, 13.25. I tried this one in Desmos. It would not work. Whenever I tried this one in Desmos, I think it did not have enough points, because if I added a couple more points, it would work in radians, which is weird because it wouldn't work in radians for the other problems. But so with this, you would want to do like we did on the tide problem we tried to do and couldn't do because our calculators would not work. 4:30 a.m. is going to be 4.5. 10:50 a.m. you're going to have to do 50. Oh, I'm sorry, that should be 10:51. So you'd have to do 51 divided by 60, and you get 10.85. And then 4:53 p.m., you're going to do 53 divided by 60, which is going to give you 0.883 repeating. But you're going to have to add 4 to that, and then also add 12 because it's p.m. So, and you need to go like military time. So 16.883 repeating. And so 13.25, 1.88, and then 13.25. Now, I don't think the calculator will work. I haven't tried it. Desmos does not work. Let me just check real quick. I'm pretty sure this is not going to work. And then it does not. It does not work if you try to do this. I think you're going to have more data points for this to work. So what you're going to have to do on this problem is you're going to have to think about this. You're going to have to think about this. You're going to have to think about this in terms of writing it by hand. So you could add the table just so it puts the points there, but it doesn't work as far as the equation. So 4.5, 13.25, 16.83, and if we go over here, you can see the graph. So, how would we find the midline for this? Okay, so all right, and so if we divide that by 2, it gives us 5.685. So let me do y equals 5.685. Does that look like it's in the middle? No. You're on the right track. If you want to know the number between two numbers, that number's the average. How do you find the average? Add them together and divide by 2. So if you add 13.25 and 1.88 and divide by 2, that gives you 7.565. Does that look better as far as being in the middle? That's probably closer, right? So that'll give you the midline. Well, now that you got the midline, you could find the amplitude, right? You could also find the period. How could you find the period? Period is how long it takes for the graph to repeat, right? So that would be high tide to high tide. So if we took the time for high tides and subtracted them, that'd give us the period, and then we could put that into our equation. And then phase shift, you just kind of have to see what works with the equation, but you can figure it out. You can see right here, our high tide is at 4.5, whereas it's actually probably a little bit easier to use cosine for this if you're trying to do it by hand. So where should the high tide be if it were a cosine function? It would be right here on the y-axis, right? So you got a phase shift of 4.5 to the right in this case. So that's all I'm going to tell you for right now. We'll go over this one. I want you guys to work right now. I want you guys to try this one right now, and then try 13 if you get done with that, and then with about 5 minutes.